Good morning, good afternoon, good evening. My name is Benjamin, a PhD candidate at the University of Energy and Natural Resources, Ghana. And I'm here to present on the evaluation of Kokoligu Reservoir using spatial techniques in the Upper West region of Ghana. This is an ongoing work. We are trying to understand the climatic variables or potential variables that are leading to the reduction in volume of this reservoir during the dry season. Reservoirs are serving as important water resource infrastructures for several water usage, such as agricultural activities for attaining food security, industrial purposes, domestic purposes. However, over-abstraction and sedimentation, rise in temperature, low rainfall are serving as a driving forces for the sustainable management of these resources. And generally, you realize that farmers in the global south, that is a sub-Saharan Africa, are most often than not faced with water shortage, water scarcity during the dry season, and as a result of high temperature leading to evaporation and low rainfall, which are expected to worsen due to climate changes. And of course, this reservoir, as mentioned, is serving as the main water source for agricultural activities around the communities here and other domestic purposes. And of course, we have to look at the the challenges the dam is facing as of now. This community is found closer to the Burkina Faso border, where temperatures are ranging 22.6 degrees Celsius to 40 degrees Celsius, depending on the year, the period of the year. And it's only one rainy season around this catchment. And relative humidity or humidity ranges 70 to 90%. And most often than not fall to 20% during the dry season. So the method used for this work was machine learning techniques in the Digital Earth Africa platform. So if we look at this statistical formula, this is the data that was plotted. The y sat t and t sat small t is a trend at a time, and the c is a cyclical movement of the peak or the cyclical movement of the trend at a time, and seasonal trend at a time, and I sat t is the errors or the random and the noise at a random point. So basically, Landsat surface temperature and era 5 air temperature data from 1984 to 2020 were used for the temperature time series trend over the catchment. First of all, so we plotted a true color of 1984, comparing it with surface temperature of 1984, the same year, and we did likewise for 2020, and we realized that the temperatures in 2020 are as high as compared to the 1984, which shows that there has been some changes over the period. So we plotted the data at air temperature at 2 meters above 2 meters, and if you look at the trend, you could see there were some rise and falls over the years. So if you critically look at the time series trend, you realize that after the year 1984, there was high and the temperatures dropped, and around 1988 there was a rise. Basically around 1988 there was a rise in temperature and it's fall again. But if you critically look at it, you realize that after 1982 there was a rise and fall till the year 2000, where there has been a constant rise in temperature, though there has been some falls here, but you realize that they have not been significant. And if you look at after 2012 or 2013, you realize there had been a high rise in temperatures, though there has been some fall after 2016, but then this fall has not been significant, and there's a constant rise in temperatures. And if you look at the seasonal temperatures, the seasonal plot, you realize that there has been a seasonal fall and rise in temperatures. And if you look at the residuals, you realize that there was some good fitting here, which also shows that there has been a constant rise in temperatures. And it basically shows that temperature trends, there has been a high seasonal uprise in temperatures, indicating influence of evaporation or evapotranspiration in the catchment. And further results shows that there was a decline in the earlier years of this analysis, that is between the 1989 and 1998. However, much of the strong upwards and seasonal trend of the temperature rise was observed after the year 2000. And plotting the surface temperature along through color images also further shows a spatial pattern changes between the 1984 and the year 2000. And I must acknowledge the Digital Earth Africa platform, where we were able to analyze this data, and we are still carrying some of the other analysis over there. Thank you.